Okay, for what we have in section 2.2 as a sample problem that we have in Aleks online, okay, we have looking at solving for x, and here we have 6x minus 12 quantity, and we have times the quantity of x squared plus 8x plus 7. And we have is equal to 0. And now these terms or expressions I can factor. Now for 6x minus 12, if I were to factor, I have 6 times the quantity of x minus 2. For x squared plus 8x plus 7, if I factor, I have the quantity of x plus 7 times that of x plus 1 is equal to 0. Now we have 4 factors, but only 3 are in x. So we have, upon utilizing the zero product property, if I set the x factors each equal to 0, if x minus 2 is equal to 0, I have x is equal to 2. If x plus 7 is 0, I have that x is equal to negative 7. And as for x plus 1 is equal to 0, I have x is equal to negative 1. So in carrying over to what I have here, and we have x at 2, negative 7, and negative 1. And if I check the result, and for the feedback, okay, this result is correct. Okay, now we have, as a second problem, it says suppose that the polynomial function f is defined as follows. And here we have this function we have in factored form, and we have f of x equal to 4x times the quantity of x minus 13 times the cube of x plus 7. And it says to list each zero of f according to its multiplicity in the categories below. So we're looking at zeros of multiplicity 1 and 2 and 3. Now, for what we have in the case of this item, okay, so you have f of x, and we have is equal to 4x times the quantity of x minus 13. And we have times the cube of x plus 3. And if I were to determine the zeros, okay, so we have with the factors here. So we have with x, if I set 4x equal to 0 or just x equal to 0, have x is equal to 0 for x minus 13. If I set x minus 13 equal to 0, I have that x is equal to 13. And we have, in the case of the cube of x plus 7, if x plus 7 is equal to 0, I have x is equal to negative 7. And for what we have in the case of the multiplicity, okay, and we have in this one case, you have x equals 0 stems from just x, which you could regard as being raised to the first power. So you have that multiplicity is 1. X equals 13 is equal to the quantity of x minus 13. There's no explicitly raised power. And you could read this as the quantity of x minus 13 to the first. So 13 has a multiplicity of 1. Negative 7 stems from x plus 7 to the third. And we have with that degree, this signals that negative 7 has a multiplicity of 3. Now, for the zeros of multiplicity 1, I have 0 and 13. And since I don't have any square expressions for the zeros of multiplicity 2, okay, and we have in this result, okay, so I have none. And for the zeros of multiplicity 3, okay, that is going to correspond to negative 7. And checking the result, okay, and that is correct. Okay, now it says to find all the y-intercepts and x-intercepts of the graph of the function, where we have the function is f of x is equal to 2x cubed plus 12x squared plus 6x. And we have for this one, okay, so you have y is equal to f of x is equal to 2x cubed plus 12x squared plus 16x. Okay, and if we were to look for the y-intercept, okay, and again we have for the y-intercept you're setting x to 0 while solving for y. So we can say we have y is equal to f of 0, and if I set x to 0, now for the y-intercept, okay, what we're going to have in effect, okay, is that for our y-intercept. Now we're not going to put this in coordinate fashion. We'll just put this in terms of what we have y set equal to. Okay, so that is going to be at 0. Now, on the other hand, okay, now in looking at solving for the x-intercepts, this time we're looking at solving for x as y is set to 0. So we have that 0 is equal to 2x cubed plus 12x squared plus 16x. Now we have among the terms, now the greatest common factor is going to be at 2x, and we have 2x into 2x cubed, so that's going to be x squared plus 6x plus 8. So we have a trinomial that can be factored. And if I set each of the factors to 0, all right, so we have a 2x, have the x factor, x plus 4, and x plus 2. And if I set to 0, so for 2x equal to 0, I have x is equal to 0. For x plus 4, I have x equal to negative 4. And for x plus 2, if that is set equal to 0, I have x is equal to negative 2. So we can say that for the x-intercepts, okay, now I'm not going to put in the y-coordinate, just the values of x. So we have 0, negative 4, and negative 2. And checking the result, and that is correct.